Let's solve a real-world problem about maximizing revenue for a baseball stadium. Here's our problem. A baseball stadium holds 55,000 spectators. At a ticket price of $10, the average attendance has been 27,000 people. A market survey shows that for every $1 decrease in ticket price, attendance increases by 3,000 people. Let's start by finding a function that models the revenue. Let's call the ticket price X dollars. Then the attendance will be 27,000 plus 3,000 times the decrease from $10. So our attendance function is 27,000 plus 3,000 times 10 minus x. This simplifies to 57,000 minus 3,000x. The revenue R of x is the price times attendance x times the quantity 57,000 minus 3,000x. When we multiply this out, we get negative 3,000x squared plus 57,000x. Now, let's find the price that maximizes revenue. Here's the graph of our revenue function. It's a parabola opening downward, so it has a maximum value. To find the maximum, we take the derivative and set it equal to 0. The derivative is negative 6,000x plus 57,000. Setting this equal to 0 and solving. Negative 6,000x plus 57,000 equals 0x equals $9.5. Since the parabola opens downward, this critical point gives us our maximum revenue. Finally, let's find the price where revenue becomes 0. We need to solve negative 3,000x squared plus 57,000x equals 0. Factoring out x times negative 3,000x plus 57,000 equals 0. So x equals 0 or x equals $19. Since x equals 0 means free tickets, and $19 is our higher price, $19 is the price where revenue becomes 0, meaning no one would attend the game. Let's summarize our findings. The revenue function is R of x equals negative 3,000x squared plus 57,000x. The optimal ticket price is $9.50, and revenue becomes 0 at a price of $19.